What if I told you that changing a single number in your web browser's address bar could give you total access to the bank statements, private messages, or medical records of millions of strangers? It sounds like a movie trick, but it is one of the most common and devastating security flaws on the internet. It's called an IDOR vulnerability. Today you're going to see exactly how it works, watch a live demonstration of how it's exploited, and learn the simple fix that stops it dead in its tracks. Let's dive in. Before we touch any code, let's understand what IDOR actually means. It stands for Insecure Direct Object Reference. That sounds complicated, but let's break it down into plain English. A direct object reference simply means a website uses an explicit identifier, like a number or a file name, to fetch a specific piece of data from a database. For example, when you view your profile, the URL string might look like ID equals 1001. The insecure part happens when the application completely forgets to check who is asking for that data. To visualize this, imagine walking into a busy coffee shop. You pay for your drink, and the barista hands you a receipt that says order number 45. When your order is ready, you go pick it up. But what if you look at the tray next to yours, notice it has a premium pastry on it, and simply tell the barista, "I'll take order number 46 too." If the barista just hands it over without looking at your receipt, checking your card, or verifying that you actually paid for it, that is an IDOR flaw. The order number reference is direct, but the verification is completely broken. Let's see how this plays out in a real application environment. Here, we are looking at InfoSecMastery, a custom banking application I built specifically for this demonstration. Let's log into the application as an ordinary authorized user. Once authenticated, we land on the main welcome page, which displays our standard financial details like our current balance, monthly spendings, and basic account overview. Everything looks clean and secure, but watch what happens when we click over to view our account profile. The browser immediately sends a request to the backend server to transfer us to our profile view. Take a close look at the URL string right here at the top of the browser. It points directly to an account ID of 5001. Everything loads exactly as expected because this is our data. The underlying logic here is straightforward. The server reads that get parameter in the URL, queries the database for the rows tied to account ID 5001, and retrieves those records for our screen. But look what happens when we shift our mindset and act like an attacker. We don't need sophisticated exploitation frameworks, and we don't need to write complex scripts. We simply place our cursor inside the browser's address bar, delete the number 1 at the very end of the string, and type the number 2. Then we hit enter. By modifying that single digit, we force the application to make a completely new request to the database, ordering it to retrieve the information linked to that newly modified identifier, 5002. Just like that, the server blindly hands over the private account details, email addresses, and transaction histories of an entirely different user. Because the application's business logic only checked if a user was logged in, rather than verifying if the right user was authorized to look at that specific database record, we just successfully breached a financial account using basic parameter tampering. So, how do we fix this as security professionals and developers? IDOR isn't a flaw in your network firewall, it's a flaw in your business logic. Fixing it requires 2 core pillars of defense. First, implement strict object-level access control. Every time a request comes in for a resource, like an account ID, the backend server must look at the user's active session token or cookie and ask a fundamental question. Does the authenticated user actually own the resource they are requesting? If the session validation says user A, but the URL is asking for user B's data, the server must reject it immediately and return a 403 forbidden error. Here's exactly how this looks in action on our enhanced banking application. I am currently on my profile page. If I try to manually modify the ID to access the profile of a completely different user, the server instantly intercepts the request. Instead of leaking data, I'm met with an access denied message, explicitly explaining that I am not authorized to view other people's profiles. Second, stop using predictable, sequential integers in your user-facing parameters. Instead of labeling database rows as 1, 2, 3, or 5001, use universally unique identifiers, or UUIDs. These are long, random, unguessable strings of characters. Even if an authorization check fails, a malicious actor cannot guess the unique identifier of another user's account, completely shattering their ability to perform bulk automated data scraping. If we look back one more time at our enhanced banking app, we can see the second layer of defense deployed in real time. Look closely at the address bar. The simple, sequential user ID has been replaced by a newly updated, long, randomized identifier. If an attacker tries to change a single digit or guess a random string to find another account, the server returns a user not found error message. Because guessing a valid ID is now mathematically impossible, bulk scraping is completely stopped. IDOR proves an essential lesson in cybersecurity. Hacking isn't always about writing complex malware. It's often just about understanding a website's logical rules better than the person who built it. If you're a beginner trying to learn this field, you already know that theory only gets you so far. You need hands-on practice to truly build a proper engineering methodology. If you want to test the exact InfoSecMastery banking application lab that we went over today, you can download the entire environment directly from the link in the description down below, set it up locally, break it yourself, and practice patching the flaw to see both sides of the equation. Focus on the methodology, keep building your labs, and I will see you in the next video.